The arrival of an interstellar visitor. The interstellar visitor has returned, and it is glowing brighter than anyone anticipated. The mere idea that a body from beyond our solar system could strike Mars stretches the imagination. For generations, we have thought of comets as distant, fleeting travelers, objects that pass by quickly, leaving only a brief trace of their presence. Yet here is one moving along a trajectory that may intersect with a neighboring planet, changing our understanding of celestial risk and cosmic interconnectivity. From the moment this data was observed, scientists across the globe sprang into action. Trajectories were recalculated, physical properties were examined in extreme detail, and complex models were developed to predict what a collision might mean for Mars. Imagine a comet born around another star, ejected perhaps millions or billions of years ago, traveling silently through the void until it finally enters our solar system. Now picture it hurtling toward a planet humans have begun exploring, carrying with it matter that may have formed in an entirely different stellar environment. Before diving deeper into the science, make sure to hit the like button and subscribe for updates on this unfolding event. The visitor, known as 3I, Atlas, is remarkable. It is only the third interstellar object ever observed entering our solar system, following the path of Oumuamua and 2I, Borisov. However, its trajectory is far more extreme than its predecessors. Observations show a hyperbolic orbit with an eccentricity far above unity, meaning that it was never gravitationally bound to the Sun. This object is a genuine wanderer from the stars, a visitor traveling on its own cosmic agenda. Spectroscopy using the James Webb Space Telescope, JWST, reveals that 3I, Atlas has a coma rich in carbon dioxide, with a surprisingly low water content compared to typical solar system comets. This unusual composition hints at a formation environment very different from anything we have observed before. Perhaps the comet formed in a system with little water or under conditions that led to unusual chemical processing. Its journey toward the Sun has aligned it unusually closely with the plane of the planets. Unlike most interstellar visitors, which simply skim past, its inclination and timing place it alarmingly near Mars' orbital path. The latest calculations show that its closest approach to the Sun, the perihelion, occurs between Earth and Mars. The flyby of Mars itself is happening within a narrow margin, and with each new observation, some scientists note that the missed distance may be shrinking. These observations provide precise measurements of velocity, trajectory, and composition, giving astronomers high confidence that this interstellar object could impact Mars. In the world of astronomy, predictions tend to be conservative. The idea of a direct collision from a hypervelocity interstellar object is virtually unprecedented. The implications are immense. Mars, a planet with a thin atmosphere, orbiters and rovers on the surface, and possibly human outposts in the future, would face consequences of extraordinary magnitude. An impact at tens of kilometers per second would release energy many orders of magnitude beyond any human-made explosion, creating enormous craters, shock waves, and ejecting debris into the atmosphere. The consequences extend beyond immediate physical damage. Exploration plans, robotic missions, and Martian infrastructure could all be disrupted. The timing of the impact matters greatly. Would orbiters be overhead, rovers transmitting, or even human crews potentially present? From a scientific standpoint, this collision is a once-in-a-lifetime opportunity. It would deliver truly foreign material to Mars. The comet's CO2-dominated coma, dust, ice, and exotic compounds could embed into the Martian surface, creating ejecta containing pristine interstellar matter. Rovers or landers in the area might capture images of dust plumes, seismic waves, and surface collapse. Orbiting spacecraft may monitor debris dispersal, atmospheric disturbances, and the dynamics of ejecta clouds. Even the smallest fragments could pose risks to satellites. High-speed fragmentation could create secondary projectiles, extending the hazard zone beyond the immediate impact site. The event also raises questions about planetary protection. How should scientists handle exotic organic compounds or isotopic signatures from another star system? Could Mars temporarily become a laboratory for Mars as a laboratory for interstellar science? The implications of this event stretch far beyond Mars itself. Interstellar objects are no longer mere curiosities, they are potential hazards. Space agencies must reconsider how they map near-planet space, taking into account bodies arriving from beyond the Sun's gravitational domain. Detection, monitoring, and tracking of interstellar objects become essential, and preparations must be flexible to account for unpredictable behavior. JUIC's observations provide more than just trajectories. Its infrared instruments reveal composition, outgassing behavior, dust properties, and potential fragmentation processes. These details are critical. A CO2-rich nucleus may fragment differently from water-dominated comets, producing a wider debris field or a shower of secondary fragments. Timing is crucial. 3I Atlas is predicted to reach perihelion around October 29, 2025, at roughly 1.36 astronomical units, crossing Mars orbit in early October. The window for observation, preparation, and risk mitigation is narrow, emphasizing the need for international coordination. This event presents unprecedented scientific opportunities. Surface rovers, orbiters, and Earth-based telescopes can collaborate to observe the impact in real time. Dust plumes, seismic activity, atmospheric changes, and chemical mixing can all be monitored. Mars could become a collector of interstellar materials, offering insights into isotopic ratios, exotic organics, and molecular chemistry formed in alien star systems. Future missions could retrieve these materials without leaving the solar system. The event also highlights operational and defense considerations. Orbiters may need repositioning to avoid debris, while rovers and landers must consider dust and ejecta hazards. High-velocity fragments could reach the surface with minimal atmospheric deceleration. Mission planners and scientists must prepare for both observational opportunities and operational risks. Culturally, the event captivates the imagination. Humanity witnesses a cosmic traveler from another star system colliding with a neighboring planet. Media, artists, and storytellers will transform the event into narratives of exploration, interconnectivity, and cosmic perspective. The collision becomes not just a scientific milestone, but a shared human experience. On a planetary scale, the impact may create a new geological layer, marking a stratigraphic boundary unique to interstellar material. Future geologists could refer to it when studying Mars history, much like Earth scientists refer to the Cretaceous-Paleogene boundary. In addition, seismic waves generated by the impact could penetrate deep into Mars' crust and mantle, providing data on planetary structure that would otherwise be inaccessible. International collaboration is unprecedented. Agencies, observatories, and citizen scientists coordinate to observe, track, and analyze 3I Atlas. The shared goal transcends competition, uniting the global scientific community. Lessons learned from this event will inform planetary defense strategies, early warning systems, and interstellar object tracking in the future. JUIC's role is particularly notable. Traditionally focused on distant galaxies, the telescope now demonstrates its versatility by monitoring an interstellar object in our solar system. Its spectroscopy may reveal isotopic ratios and chemical signatures that challenge our understanding of stellar formation and nucleosynthesis. 3I Atlas may carry elements forged around other stars, and Mars becomes a collector plate for cosmic relics. Finally, this event provides perspective on time and space. 3I Atlas has traversed the galaxy for millions of years, finally intersecting with Mars at a moment when humans can observe it. Its journey reminds us that the solar system is not isolated, it is part of a vast galactic network. Every fragment, every particle, becomes part of a cosmic exchange, connecting star systems and inspiring humanity to explore, understand, and marvel.